Assalamu alaikum, my dear cadets of class 9. Welcome to my online physics class of Burishal Cadet College. Due to the ominous cloud of Corona, you are not able to stay at your second home. That is, I am talking about your cadet college. So, our academic program is being hampered. That's why this online effort that has been arranged by the authority of Burishal Cadet College. I think this program is very, very excellent for us, and we are getting benefited from this program. You know it very well that we are going or passing through a very rough and tough situation. I'm talking about COVID-19. There is a picture, you are looking at this picture and try to follow this prevention and stay home, stay safe. Before commencing my class, I would like to introduce myself. This is Mr. Kamrujaman Khan, lecturer, Department of Physics, Burishal Cadet College. This class for class 9 subject physics, chapter 6, and it is symbolized by effect of heat on substance. You know it very well that this class is the continuation of our previous class, so no more delay here. Today's topics are vaporization, evaporation, transformation, thermal heat capacity, calorimetry principle, and effect of pressure on melting and boiling point. Learning outcomes. After the end of my today's discussion, great, you will be able to explain its specific heat and heat capacity, explain the principle of measurement of heat, explain the effect of heat in changing the state of matter, explain melting, vaporization and condensation, explain melting and boiling point. You will be able to explain the effect of pressure on melting point. You will be able to explain boiling and evaporation. You will be able to explain the latent heat of fusion and vaporization. You will be able to explain the cause of cooling and evaporation. And finally, you will be able to explain the influence of factors on vaporization. Key points of my today's discussion, please have a look. Okay, in my previous class, I have discussed about the expansion of substance. That is, I have discussed about the expansion of solid and liquid. Okay, I will discuss about the expansion of gas. You know it very well that gas can be compressed very easily comparatively the liquid and solid. That is, by applying pressure, liquids or solid cannot be compressed very much, but a gas can be compressed very easily. Therefore, at first we have to know the relation between the pressure and volume of a gas, and this relation is also called the equation of ideal gas. Okay, we have to know what is this equation. Okay, let's see. Volume of a gas is symbolized by V. It is inversely proportional of pressure. That is, if you increase the pressure, then you will get small volume, and if you decrease the pressure, then you will get large volume of gas. And there is a famous another law or equation, that is V is proportional T. That is, if you apply heat, that is, application of heat means you are getting higher temperature. Due to the higher temperature, you will get so much volume. That is, V is proportional, directly proportional to the temperature. If you increase the temperature, you will get large volume. If you decrease the temperature, you will get small volume of gas. Okay, let's see this figure. Yes, greater volume, lower pressure. This is the indication of volume, and here pressure is low. Okay, and this is the indication of volume, but here pressure is high. And now our figure number 2. Here you are applying temperature and you are getting so much volume. So, dear boys, now you are looking towards the video about that is about the expansion of gas. Let's see.
I'm now going to take this inflated balloon and I'm going to quickly cool the molecules by placing the flask in cold water. Watch how the balloon reacts.
Yes, my dear boys, I think you have got clear concept about the expansion of gas. Here, when you are applying heat on the gas, then this balloon is puffed very much. And when you are quenching this bottle inside the cold water, then this volume of this balloon is being decreased. Now I am going to discuss about our next topic, effect of temperature on change of state. Okay, you know about fusion. Fusion means the temperature at which a solid substance starts to melt, and this process is called fusion. To transform a substance from solid to liquid by applying heat is called also fusion. Latent heat of fusion. This is our very interesting term, latent heat of fusion. Okay, my dear boys, look at my drawing. Let us suppose it is a ice, and if you place this ice in our open atmosphere, this ice starts to melt very slowly, and when this ice starts to melt, at that time this ice will get or absorb heat from the atmosphere. Okay, and after absorbing heat from the atmosphere, this ice will be melt totally into water. That is called ice melted water. That is called ice melted water. Okay. Now, the temperature of this ice and the ice melted water, the temperature of this ice and ice melted water is same. Ice melted water is same, that is 0 degree. Okay. And ice is 0. Okay. So there is no difference between this temperature, but it is very clear that water and ice are two different state of matter. Water is liquid state and ice is solid state. So it is very clear to all of us that this state has been changed, but temperature remains same. Okay. Now we are going to define latent heat of fusion. Okay. Have a look. The amount of heat required to transform the solid into liquid is called latent heat of fusion, and in this case the temperature of two states will remain same, that is 0 degree Celsius to 0 degree Celsius, and it is defined by a process that is LF. L for latent, F for fusion, latent heat of fusion, and it is our fixed value, that is 3.36 10 to the power 5 joule per kilogram. Okay, now latent heat of vaporization. Okay, latent heat of vaporization. What is latent heat of vaporization? Suppose you are heating water and this water is absorbed heat from your applied heat, that is after absorbing heat this water starts to boil. Before starting to boil, the water reaches temperature that is 100 degrees Celsius. Okay. At the very instant of reaching 100 degrees Celsius temperature, water starts to boil. Okay. So the temperature of boiling water is also 100 degrees Celsius. Okay. So here it is also remains same temperature of water, boiling water, and the temperature of 100 degrees Celsius water is same. So the amount of heat required to transform the liquid into gas, the amount of heat required to transform the liquid into gas is called latent heat of vaporization, and it is 100 degrees Celsius to 100 degrees Celsius, and this is also defined by a letter that is L heat. L for latent and V for vaporization. Latent heat of vaporization, and it is fixed value. So you have to memorize these two value. You have to memorize these two value. Okay. Condensation, the process of converting gas substance into a liquid state is called condensation. Okay. Let's see our flow chart. Yes, this ice that is having 0 degrees Celsius transform into water of 0 degrees Celsius, and when it is boiled and it starts to vaporize, that is 100 degrees Celsius to 100 degrees Celsius, it is called vaporization state. And when this vaporization state is being cooled, then we are getting from this gaseous state to water state, and from water state we can get ice, that is called also freezing or solidification. This is called freezing or solidification. Okay, let's see this video.
Explaining process involved in change of phases. Continuous supply of heat to a mass of ice converts it to liquid and then to steam. Mass of ice absorbed heat energy and melts into water. This change of state from solid ice to liquid water is termed as fusion. Water absorbs heat when heated for few minutes and vaporizes eventually. This change of state from water to steam is called vaporization. Vaporization of a matter is a process of phase transition from liquid to gaseous state. Furthermore, steam releases its heat and converts into water droplets when collected in a vessel. The process of transiting phase from steam into water is termed as condensation. Condensation is the change of physical state of matter from its gaseous phase into liquid phase. Temperature of the system remains constant during phase change. During phase change, temperature remains constant even though heat is absorbed or released by the substance. Let's illustrate this. When ice temperature of the ice vessel remains constant at 0 degrees Celsius till all ice has melted. In spite of supplying heat to ice, its temperature remains constant. This fixed temperature at which a solid ice cube melts to liquid water is called melting point. The fixed temperature starts rising after the ice in the vessel is melted to water. Rise of temperature level stops again at 100 degrees Celsius when water starts boiling. As water boils and vapors, the temperature level remains fixed at 100 degrees Celsius. This fixed temperature at which liquid boils and changes into steam is called boiling point. Explaining what latent heat is. Heat is continuously supplied to ice, but its temperature remains constant at 0 degrees Celsius till ice melts to water. Similarly, temperature of water remains fixed at its 100 degrees Celsius during its change of state of vapor in spite of continuous supply of heat to it. This hidden heat supplied to water, which does not affect its temperature level at 0 degrees Celsius and 100 degrees Celsius respectively. During its phase transition, it's termed its latent heat. Latent heat is denoted by L. SI unit of latent heat is joules per kilogram. What happens to latent heat if it does not rise the temperature? In ice cubes, molecules are tightly bounded by strong forces and vibrate in their confined positions. The vibrations increases on heating and the molecules collide with each other and the space between the molecules increases. Consequently, ice melts to water by the continuous supply of latent heat by keeping its temperature constant at 0 degrees Celsius. The quantity of heat required to convert 1 kilogram of ice to water without change, which liquid boils and changes into steam, is called boiling point. During its phase transition, it's termed its latent heat to latent heat if it does not rise the temperature. In ice cubes, molecules are tightly bounded by with each other and the space between the molecules increases. Consequently, ice melts to water by the continuous supply of latent heat by keeping its temperature constant at 0 degrees Celsius. The quantity of heat required to convert 1 kilogram of ice to water without changing its temperature is called latent heat of fusion of ice. Likewise, temperature of water remains constant at 100 degrees Celsius. When it boils and eventually vaporizes, irrespective of continuous supply of heat, as water can only reach a high point of 100 degrees Celsius. This latent heat supplied to water sets its molecules free by breaking their intermolecular bonds without affecting their vibrating speed. Consequently, water boils and converts into steam as its boiling point. The amount of heat required to change 1 kilogram of liquid water to vapor state at constant temperature is called its latent heat of vaporization.
Okay, I think after observing this video, your concept is very much clear about the latent heat of fusion and the transformation of material, that is solid to liquid to gas to water to solid. Types of vaporization. Now I am discussing about the types of vaporization. There are two types of vaporization. Evaporation. Evaporation will happen at any temperature. Evaporation can happen at any temperature, but vaporization cannot happen at any temperature. Vaporization will be happened only for 100 degrees Celsius, only for 100 degrees Celsius. Okay, but the evaporation can be happened or can be occurred for any temperature. Okay, now we can see the definition of evaporation. What is evaporation? The temperature in which a liquid slowly changes its state from the surface into vapor state is called evaporation, or the phenomenon of transformation of a liquid state to gaseous state slowly is called vaporization. Let us suppose you are spreading water. Let us suppose you are spreading water over the surface of your floor. After some times, you will see, or you would have seen that this water is damaged. This water is damaged. Okay, it is a question, where does go this water? Where has gone away this water? Yes, this water is away from this surface, and it is happened due to the evaporation. Okay, it is happened due to the evaporation. Now, our next, boiling. You know it very well. What is boiling? And boiling temperature. You also know about boiling temperature. Okay, let's see this.
Did you get them right? Do you know the difference between evaporation and boiling? Both are when a substance transforms from a liquid to a gas. Think of a boiling pan of water. All of the water bubbles. This is because all of the particles have enough energy to become gaseous. But water standing in a pan that is not being heated by anything other than the environment can also turn into a gas. This is evaporation. Only the particles at the surface have enough energy to change from a liquid to a gas. Hence, evaporation is a slower process than boiling, even though it achieves the same state change. Both are types of vaporization.
Okay, I think your concept about vaporization, and evaporation will be clear. I should not say will be cleared. I think I should say your concept about evaporation and vaporization has been cleared very clearly. Okay. Now I am going to discuss about the dependence of vaporization. There are some factors on which vaporization or evaporation can depend. Okay, at first, flow of air. Yes, flow of air means the particles of the air is getting so much kinetic energy, so evaporation rate or vaporization rate will be increased. And the area of the exposed surface of the liquid getting more space for more radiation. Okay, getting more space for more radiation, and the rate of vaporization or evaporation will be increased. Nature of liquid, it is only it is also depends on the nature of liquid. Volatile substance evaporation rate is more, such as pentane, ethanol, camphor, naphthalene, etc. And the rate of vaporization also depends on the pressure. Okay, evaporation is inversely proportional to the pressure. If pressure is high, evaporation rate will be decreased. If pressure is low, evaporation rate will be increased. And evaporation rate is maximum in vacuum. Effect of dryness. The more dryness of air, that is called less humidity. If there is less humidity, the evaporation rate will be decreased. Okay. Temperature, evaporation and temperature are interrelated. Evaporation is directly proportional to the temperature. If the temperature increases, then the particles of the air gain more kinetic energy and particles are moved away very easily, and evaporation rate will be increased. Humidity, amount of water vapor present in air is called humidity, and humidity is inversely proportional to the evaporation. Now, thermal capacity and specific heat. Okay, thermal capacity and specific heat are interrelated. This is the amount of heat to increase. This is the amount of heat to increase 1 unit, to increase 1 unit temperature of substance. This is amount of heat to increase 1 unit temperature, 1 unit temperature of any substance is called thermal heat capacity. That is C is equal to Q divided by M delta theta, and its unit is joule per Kelvin, because the unit of Q is joule and delta theta, this is the Kelvin. This unit of delta theta is Kelvin. Okay, so we are getting joule per Kelvin now. Let us suppose an iron has an aluminum plate with a mass of 1.5 kg. Calculate the thermal energy stored in the plate when the temperature rises from 20 degrees Celsius to 200 degrees Celsius. The specific heat capacity of aluminum is 913 joule per kilogram per degree Celsius. Okay. Here we have to calculate the amount of heat. Okay. We have to calculate the amount of heat. From this equation, I can write U is equal to C delta theta. It is very easy. C is equal to 913, and temperature difference is getting from this, that is 180. Okay. Now you can get the value of the stored thermal energy. Okay. Now I am going to discuss about specific heat. Specific heat is also amount of heat that is required to
The amount of heat needed to increase the temperature by 1 degree Celsius is called thermal heat capacity.
1 degree Celsius. Can you say degree Celsius or should you say Kelvin?
Sorry, sir, 1 Kelvin.
Why is it? You were right. Okay, and you are right. You are right. You are also right for degree Celsius, because this is change of temperature. This is change of temperature. Please, you should keep it in your mind that change of temperature is equal in Celsius scale and Kelvin scale. Okay, change of temperature is equal in Kelvin scale and Celsius scale. Get me?
Yes, sir.
So you should say specific heat or thermal heat capacity for degree Celsius scale and Kelvin scale. Okay. Now,
Yes, sir, I
specific
got it.
heat. Okay, specific heat. It is also amount of heat required to increase the temperature of any body. Required to increase the temperature of any body, but this temperature should be unit and the mass of this object should be unit. And the mass of this object should be unit. Okay. Here, I'm talking about specific heat. Specific heat is defined by letter S is equal to Q over M of delta theta. That is, the mass of this object should be unit and temperature of this object should be increased by unit. So we need somewhat heat, and this heat is called specific heat. Okay, and the unit of specific heat is equal to joule. For Q we can get joule, and for M we are getting per kg, and for del theta we are getting, this is per Kelvin. Okay, joule per kilogram per Kelvin. This is the unit of specific heat. Now we can solve a math. Okay, 24000 joule heat is applied to increase the temperature of a rod of length 1 meter having mass 3 kg from 30 degree to 50 degrees Celsius. Find the specific heat of the rod. Yes, specific heat, this is our equation. So this equation is equal to Q over M of delta theta. Here you can put the value of corresponding parameter, that is 24000 for our heat, and m is equal to 1, and del theta change of temperature from 30 and 50 we are getting 20. Okay, now you can get the amount of specific heat. Relation between specific heat and thermal heat capacity. Thermal heat capacity, this is Q is equal to ms d theta or del theta. From this, S is equal to Q over m d theta or del theta, and S is equal to C by m, because C by m, Q, we have Q into m into 1 by del theta. Okay, now I can write m m okay, Sam is not here. Okay. Atik, can you hear me, Atik? Atik, can you hear me, Atik?
Yes, sir.
Okay. Q over del theta. Q over del theta, there is no Q. Okay. I am writing this equation from this equation. Okay, sir. Okay.
Sir,
One.
you were calling me, sir. I
Yes.
heard you, sir, but sir, I couldn't just reply. Sorry,
Why?
sir.
Why you couldn't just reply?
Sir, I was talking, but I thought that I just realized that you are not listening.
Okay. Can you get me? Can you get me clearly?
Sorry, sir. Again?
Can you get me clearly? You are getting my topics.
He
Yes,
was
sir.
muted. Sir,
Okay.
he was
Yes, sir.
muted.
No, I'm not muted. Can you hear me, boys?
Yes,
Yes, sir. We can, sir.
Okay. Okay.
Yes, sir.
Q over del theta. Q over del theta. It is C. Am I right? specific, sorry, thermal heat capacity Q divided by del theta. It is C, am I right?
Yes, sir.
So I can omit this, and here I can put 1 by m into C. Okay. So this is our relation between specific heat and thermal heat capacity. Okay. Specific heat and thermal heat capacity. That is, you can memorize it, or you can recall it very easily in this process. Okay, let's see. C is equal to, I can write Sm. Am I right, boys? C for heat capacity, S for specific heat, M for mass. So you can write is Sm. S for Sardar, M for Muhammad. Sm. Okay. This is the easiest process to recall the relation between specific heat and thermal heat capacity. Okay. Now I'm going to change my topic. What is the heat capacity of 10 kg gold having specific heat 230 joule per kilogram per Kelvin? You know it very well from this equation, because we have our equation C is equal to Sm. So from this equation you can get the heat capacity, that is C. Okay. The specific heat of some matters are given here. Please have a look. Specific heat for water, clay, lead, ice, copper, water vapor, and silver. Okay, please note this. Fundamental principle of measurement of heat. It is our very burning topics. Heat cannot go from one place to another place if the heat of each and every material is same. Heat can only go from one material to another material if there is temperature difference. So the body at higher temperature gives heat to the body at lower temperature until they reach thermal equilibrium, and the amount of heat given up by the bodies at higher temperature will be equal to the heat gained by the bodies at lower temperature. That is, we assume that no heat is lost in this process by any other means. Then we can write heat lost is equal to heat gained. Heat lost is equal to heat gained. It is our principle, that is calorimetry principle, that is calorimetry principle. It is our calorimetry principle. Okay. From this equation, or from this process, we are going to solve mathematical problem, and it is very important for all of us. Let's see a video on calorimetry.
Calorimetry. Calorimetry is one of the methods for the determination of specific heat or latent heat of substance. The method used is method of mixtures. According to the principle of calorimetry, when a body at higher temperature is brought in contact with another body at lower temperature, the heat lost by the hot body is equal to the heat gained by the cold body, provided no heat is allowed to escape to the surroundings. Heat lost by the hot body is equal to heat gained by the cold body. This is known as principle of method of mixtures. The device in which heat measurement can be made by utilizing the principle of calorimetry is called a calorimeter. 1. Calorimeter consists of cylindrical metallic vessel and stirrer of same material like copper or aluminum. 2. The vessel is kept inside a wooden box. Its outer surfaces are polished to prevent loss of heat due to radiation. 3. The space between the calorimeter and wooden box is filled with non-conducting material like glass or wool to prevent heat loss due to conduction. 4. Calorimeter is closed with non-conducting lid to minimize the loss of heat due to convection. 5. The stirrer and thermometer are inserted through a hole provided at the center of a lid. Calorie
Okay, let's see a math. A piece of ice of mass 100 gram is dropped into water of 1 liter at temperature 30 degrees Celsius. What will be the temperature of the water after melting the whole piece of ice? Latent heat of ice is given here. Now, we know it very well that the hot body always radiates its heat or losing heat, and cool body always absorb heat or gain heat. Okay, now the mass of ice M1 is equal to 100 gram and mass of 1 liter is equivalent to 1 kg. Specific heat of water is 4200 joule per kilogram per Kelvin. Temperature of water is 303 Kelvin because it is given in 30 degrees Celsius. That has been converted into Kelvin. Let us consider the final temperature of water is T. Then the amount of heat absorbed by ice is heat required to melt M1 LF. And the heat required to increase the temperature from 0 degrees Celsius to T degrees Celsius, because after melting this ice, water wants to get heat because the temperature of water is 30 degrees Celsius, but here the ice melted temperature is 0 degrees Celsius. So this ice melted water wants to get heat from this 30 degrees Celsius water. That's why it is M1 S T minus 0. The mass of water M2 supplies this amount of heat, so this temperature will be decreased and it becomes M2 as 303 minus T degree Celsius. These two types of heat must be equal. Yes, we know it very well from our calorimetry principle that heat gain is equal to heat lost. Here, this water of 30 degrees Celsius will be decreased its temperature, and from this water of 30 degrees Celsius, ice and ice melted water will get or will absorb heat. Now, after calculating, we are getting the value of temperature T is equal to 293 Kelvin. 293 Kelvin. Okay. Relegation. Yes, it is our very important topic. Relegations to melt a solid substance into liquid. Melt a solid substance into liquid by applying pressure and again to bring it back to the solid state. Again to bring it back to the solid state by reducing the pressure is called relegation or regulation. Sorry, regulation. If pressure is applied on a substance, if pressure is applied on a substance, boys, please listen to me. If pressure is applied on this substance, its melting point goes down. For this reason, when pressure is applied, two pieces of ice unite together to form a single piece of ice. Where pressure is applied on an ice, the melting point decreases there and the ice melts. After the removal of pressure, the melting point again goes back to the previous value. As a result, the water obtained from the fusion of ice again freezes into ice. Okay, and attaching two masses to the ends of a string, if it is placed upon the surface of an ice or of an ice bar so that the masses are hanging at the low ends, it will seem that the string has cut the ice bar into two pieces. Okay, that is, let us suppose you are sorry. Let us suppose you have placed a string with a heavy load. After some time, you can see that this string, after some time, you can see that this string has cut the ice bar into two pieces. Has cut the ice bar into two pieces. Okay. Let's see a video to observe or to clear this concept, that is regulation. Effect of pressure on melting point, I will discuss it later after observing the video on regulation. Okay. Yes. See this.
Zhruba po 15 minutách struna prošla celým.
Yes. Now we are getting a solid and a single piece of ice. Okay. This process is called regulation. This process is called regulation. Now I am going to discuss about our effect of pressure on melting point. The solid substance whose volume contract on melting, their melting points reduce with the increase of pressure. And it can simply mention by such a way, melting point is inversely proportional to the pressure, that is they melt or they can melt at a lower temperature, example wax, ice, etc. The solid substance whose volume expand on melting, okay, their melting temperature or melting point is directly proportional to the pressure. If pressure is increased, melting point will be increased. If pressure is decreased, melting point will be decreased. Paraffin, iron, copper, these are the example of such a like of or type of substance. Effect of pressure on melting point. Now, I have discussed about the effect of pressure on melting point. Now, I am going to discuss about the effect of pressure on boiling point. Boiling point changes due to pressure. Boiling point decreases if pressure is low. Boiling point increases if pressure is high. This is why those who go to big heights, that is, while you are going to Mount Everest, they have to cook something for a long time because due to the low pressure, water starts to boil at comparatively low temperature. Water starts to boil at comparatively low temperature. That's why at the surface of highest point, that is, I'm talking about Mount Everest, we are use Pepin's digester, that is pressure cooker. Pressure cookers have been made for this reason. It follows P is proportional T, that is temperature is increased, pressure will be increased. Okay, temperature is decreased, pressure will be decreased. T for boiling point. T for boiling point. Okay, boys. With this, I have reached at the termination of my today's discussion. Evaporation produces cooling in. Hello, boys. Hello. Who have raised your hand, boys? Who have raised your hand, boys? Hello. Can you get me? Okay. In summer days, the water kept in a new earthen pitcher becomes cold. Uncountable numbers of pores are these on the body of an earthen pitcher. Through these pores, water ships out and evaporates. Water ships out and evaporate. Water ships out and evaporate. Okay. To evaporate, it needs somewhat energy, and this energy is supplied by the upper water of this earthen pitcher, and the needed amount of latent heat is provided by the water of the pitcher, and as such the water becomes cold. Okay, that's why we are getting cold water from the earthen pitchers. But if the pot is or container is made from material, then there is no possibility to get cold water in the summer, okay, or during summer. But it will not happen when water is kept in the glass or brass vessel, because it has no numerous pores or any one pore. Why do we feel cold when air blows over our waiting body? Yes, it is a question for your brainstorming. Please think about this. Okay, with this, I have reached at the termination of my today's discussion. At a glance, what I have discussed today: vaporization, evaporation, transformation of substance, thermal heat capacity, calorimetry, and effect of pressure on melting and boiling point. Some sorts of questions are inserted here. Please have a look. Sample of MCQ are given here for your better understanding. Please have a look and try to solve these. Home task. This CQ is set for your home task. Please solve this. If you have any problem, please tell me. And make 20 MCQ on the basis of my today's discussion. And this is our very important part. You should be punctual about your assignment on Thursday. Okay, if you have any query, please ask me. I am here right now to solve your question. Thank you very much. Boys, can you get me? Boys, can you get me?
Yes, sir.
Do you have any doubt about my today's discussion?
Sir, I have one question, sir.
Okay, please ask me.
Well, in case of the melting point, effect of pressure change on melting point is always Does the melting point goes down due to pressure increasement?
No, it will depend on the nature of material. It will depend on the nature of material. Okay.
Yes, sir.
You have to know what you have to know the material which are melting, and during this their meltdown, its volume, whether its volume will be increased or decreased, whether its volume will be increased or decreased. It's our main criteria to understand the effect of melting point on any substance. Okay, there are two criteria I have discussed here about the effect of melting point. There are two criteria: solid substance whose volume contract or whose volume decreased on melting. When solid substance are melting, or while solid substance are melting, then their volume, whether it is being contracted or it is being expanded. Okay, on the basis of this factor, you are able to tell the melting
Yes, sir. I
point.
got it, sir. Thank
Okay.
you.
Okay. Do you have any question, boys? Boys. Okay. May I conclude here? Boys, may I conclude
Yes, sir.
here? Okay.
Yes, sir.
Thank you very much for attending my class, and I'm very proud of your nice cooperation. Okay.
Yes, sir. Thank you, sir. We are also thankful.
Okay, boys. Have a nice day. Thank you for attending my class. You
Welcome,
know,
sir.
you know it very well that we are passing through a very rough and tough situation. So don't go outside of your home and don't make a plan to go outside of your home. Pass your qualitative time with your parents and your family members. Please be attentive and punctual about your online class and assignment. Don't avoid these prevention tips. Thank you. Stay home, stay safe.